Hello everyone and welcome to Network 13. Today we're going to be talking about interrupts for the Arduino Uno, and more specifically hardware interrupts or external interrupts, as opposed to a software interrupt, which is a whole other subject unto itself. Now, of course, I own an actual Arduino Uno board, but we're not going to be using that today because I recently built up this functionally equivalent version for our last video, which is called Minimum Viable Arduino. So I figured we'd reuse this again today for our experiments. Well, what is an interrupt anyway? If we're talking about a microcontroller or a microprocessor, the processor will be executing its instructions in order, one after the other, after the other, after the other. If an interrupt takes place, which is an external event, a pin changing state, can also be an internal event, it can be a software interrupt. But the interrupt takes place, sets an interrupt flag, and the processor will stop whatever it's doing, and it will take a snapshot of the program counter and of hardware flags and of whatever else it needs to remember at that moment so that it can resume execution when it returns. It will leave and go to the interrupt service routine, which is the code that we want to handle our interrupt with. So the interrupt service routine instructions are executed, and then at the end we will return exactly where we left off, and the processor will reload hardware flags, program counter, whatever else it needs to reload, and will continue on with what it was doing as if nothing happened. So interrupts allow a processor to focus on the main task at hand, whatever that may be, and not have to worry about servicing an external event until it needs to. And we're going to see that today in the two examples that I put together. So I made a few minor modifications to the minimum viable Arduino that I had built on the breadboard here, and I'll show you what they are. First of all, I added two more LEDs. I added a red and a green on these two pins, and I also added two normally open momentary push buttons on these two pins. Now there are two internal pull-up resistors on these two pins that you enable through software. They're 20K to VCC. So these pins will be normally high. When I press one of the buttons, it will pull the pin low, and this will be the event that triggers our interrupt. So this is the first of two sketches that I prepared for today's video, and this one I call pin polling. So at the top here we declare variables for our blue and red and green LED pins. We also declare variables for our left and right push button pins. And we declare two variables to hold the state of the left push button pin and the right push button pin. In setup, we set the green and blue and red LED pins to be outputs. We set the left and right push button pins to be inputs, and we call them input pull-up, which means we've enabled the 20K internal pull-up resistor, so I mentioned this earlier. And we do a digital write to the red and blue LED pins, and we set them low, which means that the two LEDs defaulted will be off. Now in the main loop, we're going to be flashing the green LED and also polling the state of the left and right push button pins. So we're looking for a change in state here. So we do an initial read at the top of the left and right push button pins, and we store those states here in these variables. And then we do the flash on the LED, on the green LED, that is. So we bring it high for 300 milliseconds and then low for 300 milliseconds. And right after that, we do another read on the left push button pin, and if the state has changed between the initial read and this read, then we set the blue LED pin high and the red LED pin low. So we turn the blue LED on basically when we hit the left button. We also do a read on the right push button, and if the state is different from the initial read, we will turn the blue LED off and turn the red LED on. And we will be doing this over and over and over and over. So the loop has to do two things. It has to flash the LED, the green LED, and it also has to check the state of the push buttons before and after the flash event. So let's upload this sketch to the board and we'll see how it works. So I've uploaded the pin polling sketch, and as you can see, the green LED is flashing, the blue and red LEDs are off. So what I'm going to do now is I'm going to try to turn the blue LED on. So let's give this a key press. Nope. There it goes. Now we'll try to turn the red on. Red is on. Back to the blue. So you can see what's happening here. This is very unpredictable as to when it's going to happen. Also, it depends on the duration of the key press. If I hold the key down long enough, we'll change state. But a very brief key press isn't always recognized. So you can see the ambiguity that we have here in the user interface. So this may be perfectly fine for some application, or it may not be perfectly fine. It depends on what you're doing. But what we're going to do next is load the interrupt version, and we'll see how that works much better. Okay, so this is the sketch for the interrupt version of our program, which I called external interrupts. And most of this is the same as the pin polling sketch. We're defining all of the same pins here. We don't need the variables for push button state, so those have been removed. We do need, in the setup section, these two calls to this function called attach interrupt. Now, attach interrupt takes three arguments. It takes the interrupt number, which you return from this function called digital pin to interrupt, and you pass in the pin number. It also takes an argument for the name of the interrupt service routine function. In this case, this one's called control blue and control red. And then the event that's going to trigger the interrupt, in this case it's change. Now, the other things that you can pass in are low, rising, and falling. So you can detect a pin that's in a low state, detect a pin that's rising, going from low to high, or detect a pin that's going from high to low. In this case, we're using change, which means it doesn't matter if we're going low to high or high to low. It will detect that. And that's essentially what we were doing in the other sketch, is we were looking for a pin change. We didn't care if it was going from low to high or high to low. Now, the main loop is very much simplified here for this version, where all we're doing is flashing the green LED, 300 milliseconds on, 300 milliseconds off. And we have these two interrupt service routine functions. So when a left push button press takes place, we will call control blue, which is this function here. Control blue will write a high to the blue LED pin and a low to the red LED pin. So it'll turn the blue LED on and the red LED off. And when we detect a change in the right push button pin, we'll call control red, which is this function. Control red will just do the opposite. It will turn the blue LED off and the red LED on. So let's upload this to the board and see how this differs in performance from the pin polling version that we just tried. Okay, so I've uploaded the external interrupts sketch, and once again the green LED is flashing. So let's try hitting the blue button. Okay, blue. Hit the red button. Red. Blue. Red. Blue. Red. Blue. Red. I'm giving these very, very quick key presses. Seems to be recognizing the key press every single time. See how fast I can go with these. Okay, now if I hold the button in, okay, hold the button in, hold the button in. So you can see here that this is not at all ambiguous. It's you're very, very certain that you're going to get the blue LED to come on when you hit the blue button, even for a very short duration. Alright, so the main advantage of using the interrupt method here over the polling method is that the interrupt can take place at any time while the green LED is flashing, and it can be serviced at any time. Whereas when you're polling, you have to wait until the green LED has finished its flash sequence. So there will be issues with timing where you're hitting the button and causing the change of state, but it's not being detected in the polling method, where it's always going to be detected here in the interrupt method. If you enjoyed this video, please give it a thumbs up. Feel free to comment in the comments section below the video, or you can write to me at network13.contact@gmail.com. That's network13.contact@gmail.com. Check out the other videos we have on our channel, and if you like what you see, please consider subscribing. This concludes our video. As always, thank you for watching.